Hello, this is Ms. DB. In this video, we are going to go through how to solve some of the problems from the Properties of Exponents worksheet. The first part of the worksheet just goes over how to use some different tools in Word to show an exponent, how to format, and then we get into the properties of exponents. And there's a lot of them. You've had these before, you've had them in algebra and you've worked with them before, but here they are again. So the first one is the product of powers property. In words, you would say that if you are multiplying exponents or powers that have the same base, you add their exponents together. We'll go down and then across. The quotients of powers property says that if you are dividing powers and you have the same base, then you can subtract their exponent. Note that you can't have 0 in the denominator. The zero exponent property says that any number to the 0 power equals 1. That's always fun to see that one. The negative exponent property says that if you have a power in the denominator, then you can change the sign of the exponent and then bring the base up. So if you have, I'll just do a quick example. If you have 1 over 3 to the 5th, that's the same as 3 to the negative 5th. So if you change the sign of the exponent, then you can bring it up to the numerator. Also, if it was a negative exponent in the denominator, when you bring it up, it will become positive. Let's see, power of a power property. That is when you raise a power to another power, then you multiply the exponents. Power of a product property is that when you have two numbers being multiplied raised to a power, you can apply that power to each base. And finally, the quotient power of a quotient property is very similar. If you have a fraction that is being raised to a power, you can apply that power to each part of the fraction, the numerator and the denominator. All right, we're going to, this first part is just matching. Now to write your answers, you can do something like this. So A, power of a product. So here's all of our, here's power of a product, right here. The power of a product property is when you have two different bases being raised to an exponent, you can apply the exponent to each base. So you have to look for an example here where it's like that. So two different bases, and they're being raised to an exponent. It's number 6. Look, we have a base of 2 and a base of x, and they're both being raised to the 4th power. So I could rewrite that as 2 to the 4th times x to the 4th. So that is, A would be matched with number 6. And then maybe just tab over a bit, and then you'll match B to its example, and so on. And you can scroll up to read those. All right, now that we have looked over what all of those things are called and how to use them a little bit, we are going to do some problems. So the first section, just 1, 2, and 3, says expand the following numbers and evaluate. Evaluate means to find the numeric answer. Now you could do these on a calculator, but since it says expand, that means write in expanded form. So the way that you would write number 1 in expanded form, I'll just type this one, is you would just go 2 times 2 times 2, and you would do this 6 times, because that's what exponents mean. Exponent tells you how many times to repeatedly multiply the base. The base is 2. I have 1, 2, 3, 4, 5, 6 of them. That's enough. And now I need to find its value. So you could do this one by hand. It's small enough. Or you can get your calculator. Here's the calculator that is on computers. And make sure it says scientific. You can change it right here to scientific. And I need 2 to the 6th power. So this is the key right here to use an exponent. So 2 to the 6th power is equal to 64. Whoops, 64. So that's how you do these problems. First write in expanded form and then find the answer. All right, the next problems say to simplify the following expressions. So in these problems, we're not going to evaluate, we're not going to find the answer, we're going to just simplify them by writing with an exponent. So we're going to use the properties that we learned above and write these with an exponent. Let's look at number 6. It says 6 times 6 to the third power times 6 to the second power. Now you can either, and it says hint, 6 is the same as 6 to the 1. If you might forget that, you can add an exponent on there so you don't forget. So we can look back at page 1 and find which one talks about when you have the same base and you are multiplying them, what do you do to the exponents? It says that you can add the exponents. So that means that I could write this as you keep the base the same, and then for the exponent, you are going to add all of the exponents together. Don't forget the 1 on the one that didn't have an exponent. And then you are going to simplify that because 6 to the 1 plus 3 plus 2, that would be 4 plus 2 more is 6. 6 to the 6th. Now we are not going to find out what 6 to the 6th is on a calculator because with exponents the numbers get really, really big really, really fast. So it's not really important that we are able to type these into a calculator and get it. We could if we had to, but it's not necessary. Now, if you did not know how to do this problem, like if you forgot what the rule was or you weren't sure if you were using it right, you can write this in expanded form. 6 is 6. We don't have to do anything for that. 6 to the third power means you would write 6 times 6 times 6. And then what do we have? 6 squared is 6, times, my cursor moved on me, times 6. So we have 6 there, 1, 2, 3 for that one, and then 4, 5. So how many 6s do we have altogether? We have 6 of them. So we get the same answer if we write it in expanded form or if we use the rule that says that if you are multiplying like bases, you can add their exponents. Remember in number 7, this is the rule where you're dividing. There is really an exponent on that denominator. That's really 8 to the first power. Okay, let's see. In number 8, it says 2 to the 4th. I'm going to make this a little bigger. It says 2 to the 4th times 3 to the 5th over 3 to the second power. You can't use the rules and the properties that we learned about at the beginning unless they are the same base. So to the 2 to the 4th, you're not going to be able to do anything with that except write 2 to the 4th. Here's the other way you can write exponents, just as 2 to the 4th. But we can simplify the 3s, the base of 3. We have 3 to the 5th on the top. We have 3 to the 2nd on the bottom. The rule is when you're dividing, you can subtract the exponents. So 5 minus 2 is 3. So this would be 3 to the third power. You can also do it by writing out on the top, you would have 3 times 3 times 3 times 3 times 3. This is why this works. And on the bottom, we'd have 3 times 3. We still have 2 to the 4th on the top too, but we could cancel this 3 with this 3 and this 3 with this 3, and we have 1, 2, 3, 3 to the third power left. So altogether, this would be 2 to the 4th times 3 to the 3rd. If there's numbers, you do those separately. So 5 squared is 25. You could write it as 25, or you could leave it as 5 squared. And then you would do the x to the 4th times x to the 9th. Here's a division bar. If you have two different variables, remember that you can only put the d's together and the f's together. All right, in the next section, you're going to look at what happens if you have negative numbers and you're taking those negative numbers to a power. So I'm going to let you do this part. You're going to find each of these values and then look at these questions down below and see if you can figure out a conjecture, an educated guess, that would answer this question. Number 15, the answer to this is definitely yes. So you look at the values that you would get if you took negative 2 to the 4th power, and the negative is part of the base in this case. And in the second one, you just have a negative, and then you have 2 is the base. So see what happens with each of these, and whether you get the same answer or not, and what that means. All right, now we're going to do some more problems. And in this one, we're going to simplify some expressions. Simplified means that you can leave your answer with an exponent. You don't have to evaluate and find an answer. And it says, be sure answers have positive exponents. So why did I write that? Let's look here. Number 17 says x to the 6th over x to the 15th. I can use the rule that says I'm going to subtract. And when I subtract, I take the top exponent, the exponent that's in the numerator, minus the exponent that's in the denominator. So 6 minus 15 is going to give me a negative number. And it says, be sure answers have positive exponents, but I just wrote it with the negative exponent. However, we have a rule at the beginning of this worksheet that says that you can move, let's go way back to the top here for a second. This rule here, it says if you have a number in the denominator, you can move it up to the numerator and change the sign of the exponent, and that's okay to do it. It works the other way too. If I have a negative exponent in the numerator, I can move it to the denominator to make it positive. That's how we're going to write this one with a positive exponent. Where did it go? So this would be 1 over x to the positive 9th. Okay. Another way of thinking about this is if we had written this in expanded form, and I'm not going to do it all the way out, but I would have 6 x's on the top. 1, 2, 3, 4, 5. And on the bottom, I would have 15. I would have a whole bunch on the bottom, right? And when I start canceling, there's more on the bottom than the top. So I'm going to end up with, my answer is going to be 1 over x in the denominator. So the exponent will be in the denominator because there's more on the bottom that didn't get canceled out. Let's look at a couple of these really complicated looking ones. First of all, 19, I'm not going to do all of it, but it looks weird. So we have y to the negative 9th over y to the 10th. Think about this really as what would you do with just this part, this negative exponent in the numerator. And if we want to write these with positive exponents, we know that we have to drop it down to the denominator. So that's y to the 9th. But we already have something in the denominator. We had y to the 10th. Put a 1 on the top, and then you're just going to simplify what you have in the bottom, what you have in the denominator. And that's how you'll leave your answer. Let's look at number 22. So 22 looks like there's so much stuff going on. Let's write out what we got. We got 5x to the 4th over 10y to the negative 2nd times y to the 7th x to the negative 1y. First of all, the number part you can simplify by saying, well, I know that 5 goes into 10 2 times. Or you can say 5 over 10 is 1/2. So that part's taken care of. Let's make this be a positive exponent. And we do that by moving it up and changing its sign. So now in the numerator, I would have x to the 4th, and now I'll also have y to the 2nd. We still have a 2 in the denominator because this was going to be simplified to 1/2. Or you don't need the 1, but you need the 2. Now let's look at the second fraction. We've got y to the 7th. I'm going to write this as x to the 1 just so I don't forget. In the denominator, I have x to the negative 1, y. Well, I'll write the y down, but the x to the negative 1 can come up, and then the exponent becomes positive. Now, I'm not done yet. That's not very simple looking, is it? All right, we have the first fraction is as simple as it can get. It's x to the 4th y squared over 2. The second fraction, though, I can simplify this, and I can simplify this. We have y to the 7th over y to the 1. The rule is, if you have the same base and you're dividing, you can subtract their exponents. So 7 minus 1 is 6. So that has no denominator anymore. X to the 1 times x to the 1, they're the same base. I'm multiplying. I would add their exponents. So it's becoming a lot more simple, but it's not done yet. Now we are going to, first of all, I'm going to write this 2, this 1 over 2, as I'm just going to put that in front as 1/2 to make this a little simpler. So we have x to the 4th, y to the 2nd, y to the 6th, x to the 2nd. The 1/2 is not going to change, but now that we have like bases, let's change my color here. We have x to the 4th and we have x to the 2nd. Those can be combined. And we also have y to the 2nd, y to the 6th. So you're going to be able to write this as x to figure out the exponent and y and figure out its exponent. And then you'll be all done. Okay, then we have another investigation. We're going to rewrite the following exponential pattern with positive exponents. If it's already positive, leave as it is. So it's only these first ones that we would have to rewrite. So 5 to the negative 4th is the same as 1 over 5 to the 4th, and so on. So this is all this means. And these ones you would just leave as they are. 5 to the 0 power is equal to 1, so you might want to write that. Then it says to evaluate each term. That means to find its numerical value, use a calculator to help. So for 1 over 5 to the 4th power, I would do this. I do 1 divided by parentheses 5 to the 4th, and then I would close my parentheses. What that does is it tells the calculator to figure out the 5 to the 4th and then to take 1 divided by that number. Now this is quite a small decimal number, 0.0016. And then figure out the rest of these like this. And then this part goes on to the next page. You can fill that in. And then there's some practice problems that go along with that. I'm going to look at number 30. We're almost done with this. I know it's a long assignment, but it is worth more points, so it will take you a little longer, but there's not as many assignments in this folder. So in number 30, we would do 6 to the 3rd because you have to take the number to the exponent as well as the variable part to the exponent. So 6 to the 3rd, you can either leave it as 6 to the 3rd or you can figure out what that value would be. It's 216. Either way is fine. And then when you raise a power to a power, you multiply the exponents, and 3 times 3 is 9. So that's how you leave it. So these won't be as hard to simplify. There's just a few problems that might take you a little longer, like 34. Looks like a long one. And then you're done. So if you get stuck on any of these, remember to go back to what it means and always look back at that first page that has the rules summarized, the shortcuts. And let me know if you get stuck. You can stop by and we can work on these together during my online office hours or when I'm in the ASC room. Thank you very much and have a wonderful rest of your day.